So this is the final part, and this is going to be associated with what you are going to do for your own assignment. The sweat loss calculation is based upon your pre and post body weight and then accounting for any fluid or food that you consumed and urine and respiratory components. Now, because it's such a small contribution for respiratory components, that's just going to be eliminated from the calculation. So you'll see that the loss in mass is going to be associated with any urine that you produced, sweat that you have on your body that you wipe off with towels and such, and anything that you gain from drinking or eating. So it's the loss versus the gain. So to make those measurements, you'll need to have a digital scale that will weigh you to the closest tenth of a kilogram is ideal, but we'll use what you have. And some towels, a stopwatch, any kind of water bottles, a small digital scale for weighing your drink bottles. And before you start your exercise, you'll make sure you void your bladder so you're empty. Weigh yourself in just your undergarments as close to nude as possible, and weigh any of your drink bottles and food. During exercise, if you do need to use the restroom, you would want to measure that and weigh it if applicable. And after exercise, you'll weigh yourself after you towel your skin, get all the moisture off your skin, the sweat off your skin, and determine what volume or weight mass that you consumed of beverage and or food if applicable. So here's an example. Body mass of a football player in this example, 104.55 kgs, 2.5 hours of practice, consumed 1¼ kilogram of beverage, and had 2 energy bars, did not urinate during practice, and we have a post-exercise body mass of 101.00. So to get this athlete's total sweat loss and sweat rate, we plug in those values. Starting weight of 104.55, post-exercise of 101, minus the fluid and food consumed, which would be at 1.35, and no urine, so that would be a 0. So what we end up having is 4.9 kgs of sweat lost in 2.5 hours. So determine what that volume or what the sweat rate is. It's the volume of sweat loss divided by the duration. So you can get liters per, in 1 liter of fluid, 1 liter of water is 1 kilogram. And so we have when we have it as kgs, it's a very easy conversion. So 4.9 divided by 2.5 is 1.96 liters per minute. And I want to give you an example of what that looks like in terms of normalcy. So here is the normative data for athletes of what kind of sweat rate we have. And here you can see body mass, air temperature, relative humidity, exercise duration. We have a normative value of just a little over 1.0 liters per hour. But you also see that there's quite a range of value. So it gives you an idea if you're hitting on an approximate, if your values are close to correct.